Good morning, good morning, good morning. As this is getting focused in here, just kind of a preview, we are going to take a look at 9.3, which is evaluate trig functions of any angle. Before we took a look at special triangles and those angles on a unit circle. Now it's just any old angle. So bottom line, here we have a angle, standard form. What you do, here's an xy coordinate, drop that down, you create a right triangle. This is your hypotenuse. If that's xy, this is going to be your radius. Of any any triangle, we don't know the radius necessarily, unless it's on a unit circle, and those radiuses are 1, as you know. Now let's go ahead and fill this in. Sine of theta is y over x. It's y over r. Cosine of theta is x over r. Tan of theta, y over x. Now cosecant, remember, is just the reciprocal of sine, y over r, secant, r over x. And finally, cotan is x over y. Again, those are just reciprocals. Now, given a point on the terminal side of an angle in standard position, evaluate 6 trig functions. We are going to use this concept to do that. This is my x. That's my y. The point is 8, negative 6, so it tells me that that point is in the 4th quadrant because x is positive, y is negative. What I need to figure out is what r is. And we just use a Pythagorean theorem. 8 squared plus a negative 6 squared, that is going to equal 10. Now from there, all we need to do is write down what the 6 trig functions are. Sine theta is negative 3/5. Now you might be thinking, well, wait a minute, is it negative 6 over 10? Yes, it is, but if I reduce that, I get negative 3/5. Cosine of theta is going to be 4/5. Tan of theta is going to be equal to negative 3/4. And again, this is really negative 6 over 8, which reduces to 3/4. Now cosecant of theta is that reciprocal, negative 5/3. Secant of theta is 5/4, and cotan of theta, negative 4/3. Here's another one, doing the same thing. That's your x, that's your y. Now this is in the 1st quadrant because both x and y are positive. R equals 9 squared plus 40 squared. Square root of that is going to be 41. Sine theta, y over r. 40 over 41. Cosine of theta, x over r, 9 over 41. Tan theta, y over x, 40 over 9. Now we're going to do the same thing we did over here. Write down the other 3 trig functions. Nice thing is, all we need to do is take the reciprocal of what we got. For cosecant, the reciprocal for secant is going to be cosine. The reciprocal for cotan is of tangent, 9 over 40. Reference angle. Let theta be an angle in standard position. The reference angle for theta is acute angle theta, formed by the terminal side of theta and the x-axis. So I'm going to stop there and come down here real quick. So in the 2nd quadrant, this is theta here. Positive x-axis going to the terminal side, This angle here is theta prime. Now, in the second quadrant, you're going to take theta prime equals 180 minus theta, or theta prime equals pi minus theta. In the third quadrant, here's theta prime. You're going to take theta minus 180 to get the reference angle. Fourth quadrant, 360 minus theta to get the reference angle. And again, all these here are theta primes. Whoops, that's theta prime there. Sketch the angle and find its reference angle theta prime for the given angle. 7 pi over 12 is in the second quadrant. So I know this is pi over 2 up here, right? That's pi over 2. So 7 pi over 12 is going to be someplace over here. That's theta. Did it again, that's theta. So theta prime is here. So I'm going to take 12 pi over 7, or I'm sorry, 12 pi over 12 minus 7 pi over 12. That's theta prime, which equals 5 pi over 12. Nine pi over 7 is in the third quadrant because it's just a little bit more than pi. It doesn't have to be exact, but I'm just going to put it right there. So this is theta. That's theta prime. Theta prime equals 9 pi over 7 minus 7 pi over 7. So theta prime is 2 pi over 7. Next one is actually in degrees. 325 degrees is in the fourth quadrant. Somewhere over here. That's theta prime. Now notice we're always going to the nearest x-axis. Only x-axis. Theta prime equals 360 minus 325. So theta prime, 35 degrees. Now we have a negative angle. No big deal. We're still going to start in the same spot. Instead of going counterclockwise, we are going to go clockwise. Right at some place in there is my angle of theta. That's theta prime. Now to find theta prime, 360 plus a negative 295 equals 65 degrees. So that angle right there is 65 degrees. Now the next few here we're going to do without a calculator. These are all found on the unit circle. So if you have your unit circle out, take it. Or take it out, sorry. Negative 225. That's in the second quadrant. And now when I see 225, I think of 45 degrees. So it tells me that the sine of 45 degrees is 2 root 2. Next one, we have cosine of 210. What quadrant is 210 in? Well, it's in the third quadrant. Its reference angle, 30 degrees. What is a reference angle? What is a cosine of 30 degrees? Root 3 over 2, but it's in the third quadrant, and we know cosine's negative in the third quadrant, so it's negative root 3 over 2. Here we have the tan of 300. Bloop. Fourth quadrant, my reference angle is 60 degrees. The tan of 60 degrees is negative root 3. Reason it's negative is because tan's negative in the fourth quadrant. Now here I have 5 pi over 3. 5 pi, or see, I said 5 pi, I meant 4 pi. 4 pi over 3 is in the third quadrant. The reference angle for 4 pi over 3 is pi over 3. The cotan of pi over 3 is reciprocal of tangent. So that's root 3 over 3. Cotan is positive in the third quadrant. That's why this is positive. Then we have negative 5 pi over 4. Negative 5 pi over 4 is going to put me here in the second quadrant. My reference angle is pi over 4. The secant of pi over 4 is root 2. In the second quadrant, secant is negative. It's negative root 2. Next one is negative pi. There's negative pi. Doesn't have a reference angle because it's on the x-axis. So what we do is we take a look at the ordered pair. Cosecant is the reciprocal of sine here. So that means 0 over 1 is sine. So cosecant's 1 over 0, which tells you that's undefined. All right, a couple applications here and we'll be done. Navy Ferris wheel in Chicago is at a diameter 140 feet and its base is 10 feet off the ground. You board a gondola on the Ferris wheel and rotate counterclockwise 158 degrees where it temporarily stops. How high above the ground are you when it stops? There's my Ferris wheel. Not drawn to scale by all means. By any stretch of the imagination. Here's the gondola at the bottom. That distance is 10. My diameter is 140. Now it rotates 158 degrees. So this is 90 degrees. What I want to know is what that angle is right there. That angle right there is 68 degrees. 150 minus 90, 68. The radius is 7. There's 70. So what I can do is pull that triangle out. What I have is a right triangle that looks like this. 68 degrees, this is 70. I need to know that height, which is y. So what trig function deals with the opposite side over the hypotenuse? Well, that's sine. Sine of 68 equals y divided by 70. Y equals 70 times the sine of 68, which is 64.90 feet. Now what I need to do is add this 70 and this 10, so 80, I have to add 80 to this. And that's going to tell you how far above the ground you are. 144.9 feet. Last example. Horizontal distance of a projectile formula is d equals v squared over 32 times the sine of 2 pi. V is the initial velocity in feet per second. Theta is the launch angle. So what's going to happen you kick a soccer ball initial speed of 46 feet per second. The angle is 35. So that angle there is 35. How far will a ball travel horizontally before it hits the ground? So we're going to use this equation. You do not need to memorize that. I would give it to you. So 46 squared over 32 times the sine of 70. The reason it's 70 is because that's 2 theta. Now what that equals is 62.137 feet. Okay, that wraps up 9.3. Let me know if you have any questions.